So here is the solution to the previous your turn task. And this is the code we could use to find the correlation between the house price and the number of bedrooms. So let's run this line of code. So based on the result, we can see that the p-value is way bigger than 0.05. This means that there is not a significant correlation between the number of bedrooms and the house price. So now if I ask you the question about which independent variables would you include in this model, what would you say? Yes, you will probably choose size and school ratings because both of them have significant correlation with the house price, which is our dependent variable, while the number of bedrooms doesn't have a significant correlation with the house price, so we will not include the number of bedrooms in our linear regression model. So in here, the correlation test we're doing is created based on the entire data set. So sometimes you might have a really big data set where calculating the correlation may take you quite a bit of time. If that's the case, we can actually use a part of our data to run this type of correlation. And the example I'm giving you here is to use the first 1,000 rows in your data set to run a correlation test. So in here, I'm showing you two different methods to create that subdata set that includes only the first 1,000 rows of that 4 variables we are looking at. So the first way is that you can collect the first 1,000 observations from each variable, and then you can use the cbind function to add them into the same table or the same data set. And then the second way is that you can take the first 1,000 observations from this data, and then we can select the subdata set with only the variables that we want to analyze in this new correlations table. So either way, this will give you the same correlations table. Now, there are actually more ways to do this, and you can actually create random sample data set as well. So if you're interested, you can Google for alternative solutions and see which one works the best for you. So let me quickly run these two ways to generate the correlation table, and then we can create a correlation matrix with trend lines using this correlations table. So now if you look at the plot that we have in here, you will see that we actually created a scatter plot with trend lines and also the information about the correlation for each pair of variables that we are trying to analyze in this data set. So now that we have decided the independent variables we want to use in our analysis, we can start to create the actual model. So let's do a very quick recap on the descriptive model creation. So we'll first be creating a descriptive model. So we're creating a linear regression model where we're using the size and the school rating to explain the house price. And then we can actually apply this model to the testing data set, and then we can actually predict, try to see how well we can predict the house price based on this model. So let's first create this linear regression model. So we can create a new model called model, and then we can use the linear regression model function. And in here, since we have already attached the data, we don't need to specify the data in here anymore. And let's run the model and let's summarize the model. So what does this tell you? This tells you that the R-square is pretty high. It's 0.62, which means that the fit of this model is actually pretty good. And then it also tells you that the size and the school rating both have a positive impact on your house price. So the bigger the size, the higher the house price is, the better the school rating, the higher the house price is. So this is if we are doing descriptive analysis, when we are trying to use the two independent variables to explain the dependent variable, this is what we will be doing. But in this lecture, in this lab session, we're actually going to look at how to do predictions. So in order to do predictions, we're going to split our data first. So we're going to split our data into training data set and also the testing data set. Again, in here, I'm showing you 3 different methods to split your data. So the first one is to split your data based on percentage. So we can find the total observation number of your data set, and then we can use 80% of your total observation number and we will choose the first 80% from a data set as training data set and use the rest as testing data set. This is the first way. The second way is to create a random sample based on percentage. So first, again, we will be finding a total observation number, and we will find out 80% of the total observation number. Then in our training data set, we will be selecting 80% random data from the data set as the training data set. So this is what we are doing. We have already learned about the sample function before, so I'm not going to spend time on this in here. So after that, what we are doing in this line is we are using the rest of the 20% as your testing data set. So basically, we are excluding all the different records we have in the training data set too, and we are using the rest 20% as our testing data set too. The third method is to separate your data into training and testing just based on a specific number. Sorry, a typo here. So a specific number. And in here, the example I'm showing you is that, let's say if we're using the first 180,000 row as your training data set, and let's say if you're using the rest as your testing data set, then this is how we can create that. So there are, of course, other alternative ways to split your data as well. So my personal recommendation is actually method 2. This is more scientific. You're selecting random sample based on a percentage. So this will be my recommendation for splitting your data. So now we are done with splitting the data. The next thing we can do is that we can create the linear regression model based on the training data set. So this time we are going to attach the training data set so that we are no longer using the columns from the data set. We're using the data from the training data set. So we can create our first model, and the first model is going to be a linear regression model that uses the size and the school rating from the training data set to predict the house price in the training data set. To explain the house price in the training data set. So this is one way to do that. Or the second way is that you can choose not to attach the training data set. You can specify the training data set as your data in this linear regression model. So of course, this would be the way that I would recommend to use comparing to this one, because sometimes when you have too many data sets, when you're using the attach function, sometimes like you might get confused a little bit by yourself, and this will somehow create more bugs or errors in your code. So I would probably recommend this one for you to create your model. So now for your turn, for comparison, let's try to create a second model with only the house price and see with only the house size and see what how the model will look like.